Want to welcome you to my lecture today. Today, I'm actually going to be walking you through what we call logistic regression with our software. And um, why do I want to discuss this topic? Because I know the assignment for this week, we actually centered on logistic regression. And this will give you opportunity to be able to know how to probably run your code and how to interpret, okay, logistic regression model. But I first want to tell you I uploaded a video that I made on logistic regression. I've already posted that on Canvas. I call it logistic regression video. Did you see that? Okay, so make sure you check the Canvas. I uploaded logistic regression video just for you to understand more what the logistic regression is talking about. But you know what? In this lecture today, I will not only walk you through how you can implement this in R, but I'm also going to provide some clarification on logistic regression. Okay, so in the outline, of course, I'm going to walk you through the simple logistic and the multiple logistic. Now I'm going to go into an example. Of course, I introduced logistic regression to you the other time. We fit logistic regression model if we're trying to characterize a relationship between variables where the response variable is categorical. Okay, now an example of this is when you are trying to investigate factors that could influence a political candidate to win an election. You know, the response variable is basically going to be, it's either he wins or he loses. You get what I mean? Okay, it's either a politician, that competes in an election lose or win. So which means the response variable is categorical. Even before the contest, before election contest, we actually know possibility, right? We know possibility. It's either a candidate for election win or loses. Now, if we now want to study factors and that influence a candidate winning an election, one of the predictor variable could be the amount of money spent on the campaign. What about the amount of time the candidate is campaigning negatively, and whether or not the candidate is an incumbent? We have a lot of factors that can guarantee election victory. So here now, we know the response variable is categorical. Of course, we have a good numbers of predictors, the money spent, whether it's an incumbent or the number of time this particular candidate campaign negatively. Okay, now that is one example of a logistic regression model. Another example here is, if a researcher is interested in applying to graduate school, which I believe some of you, when you are done, you may want to apply to graduate school. Of course, the response variable is going to be categorical. It's either you are admitted or not. Okay, that makes it categorical. And you know what? That response now depends on a good number of factors. Okay, that may actually call your GPA, your GRE, okay, and where you finish where you have your undergraduate degree, whether it has prestige or not. Okay, so they put all that into consideration. So this is another example of a logistic regression model. Okay, now what I want to do now, I actually want to use a data set from the website of the University of California at Los Angeles, where, because they have a data set that has to do with admission, whether you are admitted or not, that is actually coded 01. Take a look at that. We're under the admit. And there are three predictors here that determines whether you're going to be admitted or not. We got the GRE, the GPA, and the rank. When I say rank, probably the rank of your undergraduate institution. You know, you are, because you are applying to graduate school. Now, this is just the first 6 data set. Okay, we have a lot of data set. That data set is on that website. If you click on that, of course, if you copy that into R, okay, if you copy that into R, if you copy the my data less than minus read.csv into R, okay, you can actually view the data set. Okay, now, before we go into inferential statistics, we need to first do what I call descriptive statistics. What do I mean by that? We actually want to have a way to summarize our data set. We want to have the understanding of this data set before we actually conduct a statistical inference. Or what are you going to do now? Since you have your data set in called my data, you're just going to do the summary. Just put summary of my data. Oh my God, it's actually going to give you the summary of all the variables involved. Look at that. For admit, for GRA, for GPA, for the rank, you actually going to have a sense of what is the minimum number, what is the maximum, what is the mean, what is the median, and so on like that. This is what we call descriptive statistics. You know, by descriptive statistics, like, you want to understand your data set, you know, that's what I mean. Now, the next thing that I actually want to talk about now is what is the standard deviation of each of the variable. Okay, that is what that guy is trying to find. The standard deviation for admit, for GRE, for GPA, the rank. Okay, now we want to present this in a table. Okay, and when we present that in a table, I actually want you to see, don't forget, presenting this in a table now, we actually want to see it in terms of rank. Like, how many rank do we actually have? We got 4 rank, right? The ranking of the institution. Now, the question now is, if your institution is rank 1, if you look at the column 1, your institution is rank 1, it is not all applicant from institution that is rank 1 that will be given admission at the end of the day. If you take a look at that, 33 was given admission from the institutions that was rank 1, and 28 was not given admission. Do you understand that? Okay, so what I have on the board is just to actually display to you, you know, the number of people that was given admission, giving into consideration the rank of your undergraduate college. Okay, I wanted to take a look at this now. If you look at the first one, I'm trying to tell R, treat rank as a categorical predictor. I'm going to say that again. If you take a look at what the predictor that I have, I got a GRE, I got a GPA and rank. The GRE and the GPA, they are quantitative predictor. Okay, how do I know? You can actually go back to the data set, take a look at that. The GRE, the GPA a quantitative predictor, but the rank is categorical. So I need to be able to tell our software that, okay, you know what, I actually want you to treat rank as a categorical predictor. And that was why I put my data $ rank less than minus factor. So I'm trying to say, treat this predictor as categorical variable. Now, how do we now run the model? This is the way you're going to do your assignment that I've already uploaded. You have some data set. Now, take a look at this now. Then you want to run the GLM admit on GRE, GPA, and rank. And you're going to indicate the family equal to binomial. Take a look at that. If you don't put GLM, if you put LM, it's only going to give you the result of linear regression. And that is not going to be appropriate. So you got to make sure that you have GLM and you indicate family equal binomial. Now, let us now see the results. As easy as that, right? We're going to see the result right now. This is the results. Now, when you have a result like this, I want you to pay attention to something in the table, in the summary table. In the summary table, you can see I got a rank 2, rank 3, rank 4. Where is rank 1? Can somebody tell me where is rank 1? Okay, go ahead. Can you say that again for rank 1? Oh, yeah. When you there's another when you set order to 0, if it is only rank that we're using as a predictor, okay, then the rank 1 will be the intercept you talk about. But here we don't only have rank as a predictor, we have GPA and GRE as well. Okay, so because of that, I'm not going to say the intercept is actually going to be representing the rank 1. So what? Okay, I think you want to say something. You said it? Very close to what he said. Actually, what happened is this. The arrow is making rank 1 to be reference. You know what I mean by reference? So it's making it a reference point. It's like it coded rank 1 the lowest. Okay, like coding rank 1 as 0. You get what I mean, right? And that is the reason, when you have a categorical predictor, the number, the one you're going to see in the table, if you have 4 of them, you're going to say 3, because it's going to subtract 1. And that very one that is not showing now is being made, is being referred to as reference. Okay, if I want to talk about rank 2, I'm going to talk about rank 2, with in relative to rank 1. If I want to talk about rank 3, it has to be in relative to rank 1. Everything rank that I'm going to talk about in the table, I'm actually going to be relating that to rank 1 that was referenced. Does that make sense? You actually going to see the way I'm going to interpret that. When you have a result like this, the estimates that you see are called log odds estimates. I told you the other time, log odds. They are called log odds estimates. Okay, give me 1 second. So they are actually called log odds estimates. Okay, they are called log odds estimate. Okay, now give me 1 second. Okay, now this is what we have as a result. Let us now go into interpretation. We need to interpret GRE. We need to interpret GPA. And we need to interpret rank. Okay, and how are we going to interpret this? Okay, Then another thing we can actually do here is how do you write the fitted model from this? If you want to write a fitted model, I told you there are two forms of that, right? We have the one in logit form and we have the one in probability form. But you know what? Let's first go to interpretation. Now, take a look at this. I want to interpret GRE. Okay. I want to interpret, if you come back here, what is the estimate for GRE? It's 0.00226, right? How do I interpret that? I'm going to say for every unit increase in GRE, okay, for every unit increase in GRE, that is what you're seeing here. For every unit increase, okay, in GRE, the log odds of admission. Look at that, log odds. It is not admission, log odd. You know why? Because the estimate are log odd estimates. So the log odd of admission, okay, versus non-admission increases by 0.002. Why do I say it increases? I actually said increases because that's a positive, right? If it is negative, then I'm going to say decreases. Whenever you are interpreting the estimate that comes from the regression, the logistic regression output, you're actually going to say the log odd. Look at that. For every 1 unit change or increase in GRE, the log odd of admission increases by that. You're always going to say log odd. You don't say admission increase, no, it's log odd. Because the estimate we have in the regression output, they are log odd estimates. Now, what about the GPA? If you go back to the GPA, if you go back to the output, look at the GPA. It's 0.80404. It's going to be the same way. For every unit increase in GPA now, okay, the log odd of being admitted increases by that. You can say the log off of admission or the log off of being admitted, you're saying the same thing. But you got to make sure you put log odd when you are interpreting your result. Okay, take a look at that. That is, now we have interpreted. I just walk you through now how to interpret the quantitative predictor in the logistic regression model. But what do I want to do now? How do we now interpret categorical predictor? That is what I want to walk you through now. We got levels of rank, right? We got rank 1, 2, 3, 4. And the one that is not showing in the table is rank 1. Then if we want to interpret, we're actually going to be making our interpretation of a particular rank with respect to the rank 1. Now, take a look at the first one. Now, if I want to interpret rank 2, let's start from rank 2. What is the sign? Negative is 0.67544, right? That is the sign. In fact, all the ranks has negative values. Let me see. Rank 2, negative, minus is 0.6754544. Rank 3, negative 1.34020. And rank 4, negative 1.55146. All the rank values are negative. If I want to interpret them one by one, I'm actually going to be relating them to rank 1. Now, take a look at this now. For example, having attended an undergraduate institution with a rank of 2, having, attended an undergraduate college with a rank of 2 versus an institution with a rank of 1. I told you, anytime I want to interpret the rank 2, then I'm actually going to say versus the rank 1, okay, because the rank 1 is actually being referenced. Now, then I'm going to say that changes the log odd of admission by that. That is how to interpret the rank 2. If you want to interpret the rank 3, you're going to go the same way. You're going to look at rank 3 versus rank 1. If you want to do rank 4, it's going to be rank 4 versus rank 1. Is there anyone who needs more clarification on how to interpret this? Is there anyone? So that is a way to interpret both a quantitative predictor and a categorical predictor in a logistic regression model. So take a look at that. So if you're maybe in another question, it could be gender. Of course, in the regression output, you're only going to see one, right? Whether male or female. The one you don't see, if you want to interpret the one you see, it has to be in relative to the one you don't see. Okay, so that's what we have. Okay, that is the way you're going to interpret every other one. Okay, because it is expected that you give interpretation to all the estimate. Like I said, they are log odd estimate, and that is the reason why we were referring to the log of admission. Log of that's why we're referring to that. Okay, the next thing that we want to do now, do you know that this guy here, the log estimates that we have, they are point estimates. You know that? We have a single result. And I told you the other time, a single result could be wrong or right. And that is why we normally go for interval estimate. Okay, so how do you get the interval estimate of that? Or what you're just going to do, you're going to confit. You remember confit of my logic, because when you were running the analysis, you actually put my logic. Look at that, say my logic. So that was why it's going to be confit of, when you do the confit of that, you're actually going to have this guy here. You're going to have the interval estimate for the intercept and for the other coefficient. Take a look at that. This is an interval estimate now. Okay, so this is the confidence interval for the coefficient estimate. Okay, so take a look at that. Okay, the next thing that I want to find out now is, can we carry out a test if is there any difference between the ranks? The school that are ranked, like 1, rank 2, rank 3, rank 4, is there any significant difference between them? If you want to carry out that, because the reason why we need to know if there is a significant difference between them, if you come back to this table here, you're actually going to see the fact that your school is rank 1 does not mean that they will admit every candidate from the school. That doesn't mean. If you take a look at what you have here, you're going to see that there are situations even where they don't even take from, those schools that are rank 1. They can look at that. And that's why we may want to know, is there any significant difference between the ranks? Okay, so that's exactly what we're doing. And if we want to do that here, we're actually going to make use of a chi-square test. That's a what test. Okay, that is a code. At the end of the day, you have to look at your p value. It's 0.001 for the test, which is less than any reasonable level of significance. Maybe compared to 0.05 or you compare to 0.01, this is less than that. And therefore, what is going to be your conclusion is that there's a significant difference in rank. Okay? Rank, it means rank 1, rank 2, rank 3, rank 4, they are not the same. The difference between them is very much pronounced. That is what we mean. It's statistically significant. Okay. That is about that. If you take a look at this, what if we know that we have 4 rank and they are not the same statistically, but we may be interested to know Is there a significant difference between any two ranks, or maybe between rank 1, rank 2, rank 2, rank 3, rank 3, rank 4, stuff like that? Now, if I want to carry out that test, this is what I'm going to use. Some of you may be wondering, what is the meaning of 0, 0, 0, 1, -1, 0? How many predictors do I have? I got 3 predictors. Okay. But one of them is categorical. It has how many levels? 4 levels. Now, if you see the first 0, the second 0, the first 0 is representing GRE. The second 0 is representing GPA. I'm not interested in them. That was why I put 0, 0. The third 0 is rank 1. The third 0 is rank 1. Okay. And the next one, if you see the one of 1 and -1, that is the rank that I'm trying to compare. Okay. I'm comparing rank 2 and rank 3. Under contrast, what happened? One is going to be the one is I'm going to assign 1 for the one, and the other one is going to be -1. It means I'm actually comparing. Is there any significant difference between rank 2 and rank 3? I can do the same for rank 1 and rank 2 if I wish to, or rank 1 and rank 4. So at the end of the day, the p-value here is 0.019. Okay, the 0.019 actually indicate that the difference between that is that, let's say at 0.01, that is less than 0.05. Therefore, the difference between rank 2 and rank 3 is statistically significant. You can also do the same. You can compare any two ranks. Why are you comparing any two ranks? Because we have realized here that the rank is significant. And that is why we're trying to see where the difference lies. Okay? Now, the next thing we want to do now. I told you the other time, there is a difference between log of odd and the odd ratio. Okay? You know, what you get in the table, in the regression output, we call them log odd estimate, right? Now, the question now is, if I want to get odd ratio without log, I'm going to say that again. How do I get odd ratio without log? Because the estimate we have in the regression table is actually log odd. Then the mathematical way to eliminate log is to take the exponentiation. Look at that. ESP, exponential of the coefficient. What are the coefficient am I talking about? The coefficient I'm talking about are the estimates. Those ones from -3.98998 to -1.55146, they are all log odd, log odd. But what if I'm not interested in the log? I'm interested in odd. Then how do I actually get odd from log odd in R? What am I going to do is to exponentiate. Okay, and the way to exponentiate that is the code, and it's actually going to return this. What I have now, it is no longer called log odd, but it is called odd ratio. You remember the other time, what do I mean by odd ratio? It is a ratio of the probability of success to the probability of failure. Now, in this case, it's going to be the ratio of the probability that you're going to be admitted divided by the probability that you are not going to be admitted. And that is why it is called odd, because it's a ratio of negative or two opposite things. Okay, this is what we call the odd ratio now. Now that we have odd ratio, these are estimates. These are point estimates. And I told you a point estimate could be wrong or right. Then we need to get an interval estimate. Okay, now what is the code? If I want to get the interval estimate, All what I'm just going to do is that confit. Look at that, confit. So ESP, C bind, OR means odd ratio. Okay, equal coefficient my logic, comma confit, then I'm actually going to get this. Now, when you look at the first one, OR, that is the odd ratio, which is a point estimate. But when you look at it, when you look at the other one, the lower end point and the upper end point, that is a confidence interval. Take a look at that. So that is a confidence interval of the odd ratio. Take a look at that. Now, how do we interpret this? We can say that for 1 unit increase in GPA, the odds, I'm not going to talk about the log anymore. I want to interpret odd now. The odds of being admitted to graduate school increased by a factor of 2.23. 2.23 for what? For GPA. Can you see the value under the OR for GPA? This time around, I'm not interpreting the log of admission. There's a difference between log of admission, okay, and the odd of admission. They are not the same. The one we did before, the interpretation we did before was on log of being admitted. But right now, we are talking about odds of being admitted. So you're going to interpret all of that under the odd ratio. Okay? If you're interpreting that, you're actually going to say odds, not log of odds. That is the difference between the two. Okay. The next thing that we want to do now, we've talked about log odd. We've talked about odd. Then we now want to talk about probability, because there are three things: log odd, odds, probability. Now, in the last lecture, I think I gave you some code. Okay, go ahead. Okay, the last slide. Oh, why they are now positive now? Because they were negative, because you have done exactly the rank. So what we are trying to say, under the log odd estimate, all the rank were negative, but now they are now positive. Now, when you take the exponential of a negative raised to power, whatever is going to give you that result. So, which means, and that is what changes the interpretation. When you were interpreting for log, is different from when you are interpreting for odd. Do you remember when I introduced the lecture, I said the log odd can go from negative infinity to positive. Right now, the odd ratio is positive now. So the reason why it is like that is because we have done mathematical manipulation, because the exponential raised to power negative value here will actually return positive. Have I answered your question? Okay, that's a very nice question. Okay, now that you're going to interpret each of that, because when you are talking about odd, you don't talk about negative in odd. The odd of, if it is 3-1, like if the odd of getting admission to not getting admission is 3-1, you know what that means? It means your probability of getting admission is 3/4. You understand what I mean now? That's what it means. So that is the relationship between odd and probability. Now, on the probability now, we want to make a prediction. We want to use, you can do that manually too. If you want to do that manually, you need to use the probability form of a regression model, okay, which is a 1/1 plus exponential raised to power. I think I gave you last week. But if you want to use our code, I want you to take a look at what I have here. Okay, we have 4 students. I mean, he said we will start by calculating the predicted probability of admission at each value. Give me 1 second. At each value of rank holding GRE and GPA at their means. And first, we create and view the data frame. The new data equal to that. Now, when you take a look at what I have here, if I have information about predictor, I can actually use a model to predict, right? If I know your GRE, and I know your GPA, and I know the rank of your undergraduate school, if I plug in those into the fitted model, I'm going to plug them into the probability form of a logistic regression model. You know what? I can predict your probability of being given admission. That is what they do in medicine before they can treat. Like, for instance, it is not all patients that will benefit from medical intervention. I'm so sorry to say that. Not 100% of all patients will benefit from medical intervention. If they really want to know whether a particular patient will benefit from medical intervention, they can fit a probability form of a logistic regression model where they're going to, if they know the predictor values, depending on what determine sources, maybe they look at the BP and so on like that of that particular patient, they plug that into the model, and that will tell them the probability of that particular patient benefiting from medical intervention. Now, the same thing here. Now, we have, let's say we have this for false applicants, okay, coming from, sorry, a single applicant, but we are, you can see 588, our GPA the same, but coming from different school. You know what we want to do now? We have 4 students. We have 4 applicants. They have the same GPA. They have the same GRE. But do you know the difference between them? They came from different school. Somebody came from a school that was rank 1. The other person came from school that was rank 2 and so on like that. Now, I want to tell you this. When you plug them in and you want to predict, the code is going to be type equal to response for probability. Your new data is actually what you have here. Okay, you've already you write a code, you put your new data. Now we can calculate the probability that they're going to be given admission. Oh my God, this is the reason why applicant, we have the same score, but the reason why some are given admission or not is because they came from different school. Take a look at that. Despite the fact they have the same score for GRE, for GPA, because they came from different school, somebody who came from an undergraduate school that was rank 1 actually has 0.517 of being given admission. In fact, he has the highest probability of being considered because he came from a school that is highly reputable, from the undergraduate school that is highly reputable. And look at the school, somebody who came from a school that was ranked the lowest, like 4, okay? Look at the probability of getting admission is 0.185. Oh my God, despite the fact they have the same GPA value, they have the same, GRE. Okay. Interpretation now, finally. In the above output, we see that the predicted probability of being accepted into a graduate program is 0.52 for students from the highest prestige undergraduate institution, and is 0.18 for students from the lowest rank institution. But you know what? We are having this prediction, okay, by holding at constant the GRE and the GPA. That's what we're doing, okay? So that is what we mean. Okay. Then we can do something very similar to create a table of predicted probability, vary the values of GRE and, and the rank. Right now, we did not vary the values of GRE. The GRE is the same. You can also have a different prediction where you have different values for GRE and the rank, and you can also make, but the reason why we're doing this is just to tell you, different candidates could have the same GRE score and the GPA, but the reason why one is highly considered to be given admission is because he actually came from, a high, a reputable school. They're on a graduate college with high prestige. I want to believe that with this, you will be able to do your assignment successfully. I believe that. But just like what I used to say, you make sure you reach out to me if you have something to clarify, and I will also advise that you should watch my video. Now, the lecture for Wednesday will be held on Zoom. There's not going to be an in-person class on Wednesday. But you know what? I'm going to have it on Zoom. Okay, I'm going to project that on Zoom. You may attend, you may not attend, because it's going to be recorded, and I'm going to share the video with you at the end of the day. But I also want you to enjoy your Thanksgiving break. And that is the reason why the submission for assignments is extended too, for the new assignment. So just enjoy your Thanksgiving break. Make sure you stay safe while while you're enjoying your Thanksgiving break. And I'm gonna use that period as well to, also have some stuff to do with my family. And then also to finish the grading for the midterm too and the practical too. But I also wanted to wash out the final exam guide will be released, and the final practice questions will be released. Or let me tell you this, the final exam is going to be cumulative. The knowledge of simple linear regression will be tested. The knowledge of multiple linear regression will be tested. The knowledge of analysis of variance will be tested. And the knowledge of logistic regression will be tested. Okay? Make sure you guys stay safe and have a lovely day, a lovely week, and lovely celebration of a Thanksgiving.
Kazim.
Oh, okay. How are you?
Yeah, I had the DRC email you, so they should have scheduled the new test now.
Exactly. I contacted them that they made mistake, and they acknowledged that they've sent, as I'm teaching now, I saw the notification from them. Immediately, I leave this place now, I'm actually going to respond. Does that make sense?
Yes. Yeah, that sounds great. Thank you.
You welcome.
Have a good break.
And you too. Yeah.